Hi everyone, let's take a look at how to select a Humifog high pressure atomizer system in CPQ. We start from the login page, where we can request a new account if we don't have one, or just log in with our credentials. After logging in, we will select the product module we want to use, in this case the humidification module. Here we are in the Search Project menu, where we can see our list of projects. Now we will press the New Project button to start a new project with Humifog. This is a new project, which is divided into various tabs. We'll start by filling out the Project Details tab, where mandatory fields are marked with a red asterisk. Project name is Humifog for Hospital Ward, Padova. We can add keywords or hashtag like adiabatic or Humifog. Customer is Padova Hospital Contractor, that we can add to the customer list. Application level 1 is Hospital. Application level 2 is Hospital Ward. Useful fields are also the validity date that can be used to track the project developments over time, and the description, where we can copy-paste and easily find the important information related to the project. We click on Save, and then we can proceed to the following tab. In the System Outline tab, we want to define the installation layout of the project. By default, you find one system and one zone. In this project, we have 3 air handling units, and we want to design a multi-zone humidification system with Humifog. We can rename the system Hospital Ward Building A and the first zone Air Handling Unit 1. Then we need to create 2 additional zones, Air Handling Unit 2 and Air Handling Unit 3. Humifog is a multi-zone humidifier that can supply multiple rack distribution systems placed in different air handling units with just one pumping station. Let's see how to design it. In the Design tab, we want to insert the air handling unit design data to get the humidification system selected for us. Let's go through the various menus we have. Here we can do the design of one system at a time. First, we can choose units of measures, like Celsius or Fahrenheit, imperial system or metric system. Then we want to choose where the humidification process will take place. In this case, we select duct configuration, as humidity will be distributed inside the air handling unit. If you need additional information, you can check the help text next to the drop-down menu. Next, we want to choose the type of humidification process between isothermal and adiabatic. In this case, we must select adiabatic. Finally, we are able to find out the design conditions of our 3 air handling units. Duct width is 2000 mm. Duct height is 1700 mm. Absorption distance is 1500 mm. This is the length of the humidification chamber from the nozzles of the rack to the drop separator. Airflow is 25,000 cubic meters per hour, while outside air on total airflow rate mix is 75%. This is the ratio between fresh air and the total airflow, that is the complementary value of the recirculation rate. In this case would be 25%. Altitude is 100 meters. Outside air conditions -5 Celsius degree, 80% relative humidity. Set point conditions 20 Celsius degree, 55% relative humidity. Now we can press the Calculate button and CPQ generates the psychrometric chart with all the transformations the air undergoes from the outside conditions to the set point. You can see the adiabatic humidification process segment here. Below the psychrometric chart, some data is calculated and printed, like the airspeed, temperature, humidity, and of course the humidification load required by the zone. Next, we can copy the data from our first air handling unit to the second one, with just one click, and then eventually change any value that may be different. On air handling unit 2, we change airflow rate to 22,000 cubic meters per hour. Then we change outside air on total airflow to 100%, and we press Calculate. On air handling unit 3, we copy the configuration and we change duct width to 1900 mm. We change duct height to 2000 mm. Then we press Calculate. The humidification load for each zone is defined. Now we can choose Humifog High Pressure Atomizer among the available products. Please keep in mind that products available in this section depend on the configuration and the humidification process chosen at the top of the page. Once we select the Humifog product line, we can see a summary of the humidification loads and absorption efficiency levels estimated for each air handling unit. In this case, you can see very high absorption efficiencies, since Humifog produces very small droplets of water, which can be easily absorbed in the available absorption distance, so that basically no water is wasted. If the absorption efficiency is lower, the required amount of water sprayed to reach set point must be higher than the calculated load. When efficiency is low, it is possible to improve it by increasing absorption distance or by reducing airspeed in the humidification section by increasing width or height. When the humidification load is provided as design data, it is also possible to use it as an input in the overriding sprayed water load free text field. At this point, we proceed to the selection of the optimal version of the pumping station and the distribution system for each air handling unit. We will go through all the options, but let's keep in mind that the default values are the recommended ones for the vast majority of installations. Furthermore, you can get hints on what option to choose by reading the help text next to each menu, or following the indications given through pop-up warnings. In the humidity production section, we fill out all the necessary information for the selection of the correct humidifier code. In modulation type, step modulation means the capacity modulation will take place by opening different groups of nozzles in the rack, and is the only option available when in multi-zone configuration. On the other hand, continuous modulation means modulating by varying water pressure through an inverter. It is available only when in single-zone configuration, and it is suggested for applications where precision in following the humidity set point is a must. Pumping station model is Humifog multi-zone touch in this case. In pump material we have brass or stainless steel, where stainless steel is recommended for applications where hygiene is critical or when humidification is continuously required for many hours. Additional option is the silicone-free stainless steel pump, often required for specific industrial applications, such as painting. For inlet water filter kit, vessel plus cartridge, we recommend having an inlet water filter before the pumping station. In this way, eventual debris coming from the feed water line installation can be stopped. Backup and rotation is a configuration where two identical pumping stations are connected in a way that if one goes down, for maintenance or any fault for example, the other one will automatically kick in and supply pressurized water in the distribution system. In this way, continuity of service is absolutely guaranteed. This is recommended for critical applications like healthcare and industry. So in this case, we will choose it. Communication protocol. Here we choose which protocols should be enabled in the Humifog system. Humifog has Modbus and BACnet embedded by default. If Connex or any other protocol is needed, it can be selected here. System drain valve. Here we can select if we want the system drain valve that is definitely recommended and how far from the cabinet we intend to install it. Humidity distribution options can be customized zone by zone. Rack model let us choose between standard or the option with wired solenoid valves that can greatly simplify the installation on field. Nozzle type, we can choose between 1.45, 2.8 or 4 kg per hour nozzle capacity. The lower is the capacity, the higher is the number of nozzles, hence the better the water distribution. Number of circuits. We can choose the maximum number of steps to group nozzles into. The higher is the number, the better is the modulation of the water sprayed. Nozzle distribution. Binary distribution means having different manifolds with a different number of nozzles, which is good for modulation and it is recommended. Uniform means having the same number of nozzles on each manifold, which is just used in some special cases. Rack type. Assembled means the rack will be shipped already fully mounted and tested. Partially assembled means the rack will arrive disassembled, but all the manifolds have the nozzles and solenoid valves mounted and tested. Rack manifolds orientation can be forced to be horizontal or vertical through this option. By default, we suggest manifolds to be aligned with the longest side of the duct or air handling unit, so that there can be less of them and the rack will be cheaper. On the other hand, if there are more manifolds, the modulation is better. Water inlet side can be left or right, and it is decided by looking in the same direction as the airflow. Drop separator modules can be in glass fiber or stainless steel. Stainless steel is recommended in applications where hygiene is critical. Main probe. Here we can choose the type of humidity probe which will provide Humifog with the main regulation signal. Limit probe is used to reduce the humidifier production where relative humidity measured in a specific point goes too high, as an additional safety measure to avoid dangerous condensation inside the air handling unit. Preheating probe is used to measure preheating level before the humidification section and to regulate the humidifier production based on that, so to ensure maximum absorption efficiency and to avoid wasting precious water. Rack shutoff valve is an option used to hydraulically isolate and exclude each rack distribution system from operating, for maintenance and flexibility reasons. In this way, it is possible to temporarily exclude one zone from the operation, while the rest of the multi-zone system keeps working. If we need to copy our design from one air handling unit to the other, we can do it with just one click on the red button. We copy the configuration on air handling unit 2 and also on air handling unit 3. The next section is Water Treatment System, or WTS. Here we can select the reverse osmosis system and decide if this will provide the water to this system or also for others. In this case, we have only one system. Distances from WTS to humidifiers are used to decide if a booster group is needed to win the pressure losses in the hydraulic line, in order to satisfy the minimum feed water pressure required by humidifiers. An external UV lamp sanitizer kit can be installed after the reverse osmosis system and is recommended in applications where hygiene is a critical requirement. Connections between WTS expansion vessel and the humidifier can be supplied in a case of low capacity model is selected. Antiscalant is a liquid needed to keep the reverse osmosis membranes efficient over time, and it comes in two versions: EN 15040 compliant and NSF certified, usually required in the food industry. In the accessories section, we find the accessories needed for the first maintenance, as pump oil, pump gaskets and valves, and water filter cartridge. Everything is set. We can press the Suggest Solution button and in a few seconds a complete list of codes is generated, comprising everything that's needed for a correct installation and operation of the Humifog atomizer, from the main components to the all accessories. In the humidity production section, we have all the components related to the humidification system core, from the Humifog pumping station to the main drain valve, the hydraulic connections needed for installing the backup and rotation configuration, and the inlet water filter. Then we have a humidity distribution section, where we have everything which relates to the different zones. In this case, all the details of the 3 air handling units we have in this project. First, we have a table describing how each distribution rack is composed in terms of nozzles, manifolds and steps. The rack resolution identifies the capacity of the rack of modulating sprayed water flow to satisfy humidity demand. The lower it is, the better the modulation. The graph on the right helps understanding how good the modulation will be, comparing humidity demand against humidity production for each rack. The smoother the graph is, thanks to the small steps, the better the modulation and the precision in following the set point. Next, we have a rack custom code, tailored to the dimension and the needs of each specific air handling unit. After that, we have a list of zone control panels to be installed outside of each air handling unit nearby the rack, a list of drop separators components to be installed at the end of each humidification section, the flexible hoses that go from the duct wall to the rack shutoff valve if selected, and the humidity probes to be installed within the air handling unit. Then we have the codes for the water treatment system, comprehensive of reverse osmosis, expansion vessel, connection kits and optionals. In the end, we have the suggested accessories to perform the first maintenance, a must for ensuring the correct operation and a long life of the system. Services like technical support, site analysis, training on products, kick-off meeting and commissioning held by qualified technicians are available and can be selected in this section. Especially in complex projects, the know-how on technical solutions and the knowledge of customer needs allow to meet or even exceed the expectations of the stakeholders. In the last section, it is possible to manually select dedicated accessories to complement the selection, like high-pressure hoses for hydraulic connection of the pumping station to the distribution rack. For this project, we know the real distances between all the parts of the system, so in this case, since we have 3 air handling units, we can add a single piece of 20-meter hose to cover the main gap from the pumping station to the air handling unit. Then we have 2 T-connections and we add 3 pieces of 10-meter hose to the racks. At the end of the page, we press the Save button to confirm the selection and apply all the changes made until now. In this way, we don't lose the work done. Here we also find the button Edit Quantity, that is used to modify the desired quantity of any of the items selected above. If we click on Proceed, we move to the next section, called Manual Selection. Here we can add any item that was not included in the Design tab, provided that we know the part number. We can do that by pressing Add Item button and writing the code, or by uploading a list of items through an Excel template that can be easily downloaded from here too. Finally, we can proceed to the last tab, which is the Quote tab. Here we have a recap of all the codes selected so far, and we can download 2 outputs: a technical offer in PDF format, complete with design data, technical info and installation layouts, and a list of codes in Excel format, easy to analyze and modify. Let's download and check the technical proposal printout. The PDF document starts with a front page with project details, a table of contents, the complete list of codes divided into categories and subcategories, and additional notes fully customizable by the end user. Following, we find a schematic drawing representing the system composition. In this case, the water treatment supplies water to the Humifog pumping station, that delivers high-pressure water to the 3 rack distribution systems. Then we have an installation drawing for humidity production components, the WTS and each Humifog unit. Every part has a reference number pointing to the below legenda and to the below list of codes, simplifying the understanding of the system also for installation technicians with limited knowledge of the product. The same information is shown for each distribution system, so for every zone calculated. Typical installation layout drawings, conditions and mechanical electrical data are summarized with the objective to make the installation work easier, both for humidity production and distribution. At the end of each zone paragraph, we also find a recap of the design conditions and the air transformations on the psychrometric chart. Let's download and take a quick look at the XLS output too. It is a very simple list of items, comprehensive codes, quantities, descriptions, categories and subcategories. This table can be most useful for editing and for importing the data into other tools. This is the selection of the Humifog High Pressure Atomizer in CPQ. You can try it yourself for free at cpq.carel.com. Thank you for watching.